Hi, my name is David Mann with XD Innovation. I'm here with Louis Feinstein from Dassault Systems, and we're going to be talking today about the accelerated device solution from Dassault Systems. This is going to be a way for customers to move forward with electronic device design. The session today is live. Thank you all for joining. You will see in the interface, if you have questions or things like that, you want to leave notes, you want to tell us how you feel about it, please go ahead and use those comment sections. Please use the kind of emoticons and things like that. Let us know what you think. If you have any questions during the show today, we will be reviewing those questions at the end. We'll try to get through as many as we can. So with that, accelerated device solution for high-tech companies. What I'm going to do is I think we should just start out with talking about some of the people who have adopted this solution, so that customers can identify what the target is for this and how it can be used. And so I'll hand it over to Louis from Dassault to kind of go over some of these.
So, welcome. Thanks for having me, David. So when it comes to accelerated device, it's not a new solution. It's been around for a long time, and we have many customers that have adopted it over the years. And here's some iconic brands. We'll start out with talking about like SoftBank Robotics. You may know them as Aldebaran. There's some really interesting living type robots, and they started out utilizing SolidWorks and the SolidWorks ecosystem, and very quickly moved over to the 3D Experience platform and have lots of experience with the platform and have grown over the years. And same with companies like Amazon Ear that you absolutely see here. Is again they started small and moved their way up, with the same type of portfolio as SoftBank, and have moved them continually to adopt and take new features of the 3D Experience platform as they expand their universe of drones. And I'm going to let David talk about Skydio. It's a real company that it's near and dear to David's heart.
Yeah. So Skydio, based here in California. I'm based out of San Diego, but they're not here. They're up a little bit further north, Northern California. Drone company, up and coming, has had a very interesting drone technology, a lot of follow me type technology with automatic avoidance systems for trees and things like that. They've got some awesome videos on their website if you all want to take a look at it later. So they've developed their drone on the 3D Experience platform. They're using our mechanical design tools, and they're on the cloud. So it's a really interesting company when you look at the types of innovation that they can do. And what we're seeing is that if you look at the news and some of the headlines recently, they're starting to get a lot of traction in the United States, not just for the recreational, but also some of the governmental areas, replacing some of the drones that have come from China that the government might be a little bit more suspicious of. Skydio, being an American-made product, is also able to compete in that area. So with that, we see the types of companies that are innovating. They're using the 3D Experience, and they're using the accelerated device solution. The question we can ask is, why would they be doing that? And there's a lot of reasons to use accelerated device. We're going to go over a lot of the content of it later, but if you look at the business reasons, how does this actually help people accelerate the product design process? Well, it cuts down the number of engineering and design iterations. It allows you to innovate faster and get to your final design much faster. We're going to show you how that happens a little bit later on in the live session today. It allows you to explore also more design alternatives. So whenever you start a project, of course, you're looking for the best product to bring to market, and you always have a lot of different ideas. And these alternatives are kind of competing with each other. Well, the platform will help you to select which one of those design alternatives is the right one, and allow you to explore a much larger design space to select the right product to bring to market. It also cuts down on the assembly process creation, being able to do that up to 60% faster. Design the way in which your product is assembled has a direct impact on the end product cost. So being able to do that faster allows you to get out more products off the assembly line, and also being able to get the product to be assembled at a lower cost. And finally, this whole concept of prototype. A lot of companies historically have been building prototypes. There's even 3D printers that help along in some key areas in that. But the whole idea in prototyping is that every time you have to build a prototype, there's a cost involved. Some of those costs are justified, and you do need to build actual physical prototypes. Others can be simulated and reduced So you can do a lot of reduced numbers of actual physical design prototypes using this system. So with that, I'd like Lewis, if you can give us, give us a quick overview. Before he gets the overview, I'm going to go over the high-tech complexity. The products in the high-tech market, and this actually goes for a lot of different industries, can be boiled down to what you see on the screen. You've got sensors and actuators that are inputting data into the system and then taking the things out and modifying the environment around them. You have some central electronics that are controlling that are providing the electricity for the sensors. You've got an enclosure, which is kind of doing a double job. It's protecting the internals, the electronics being fragile, but it's also providing the external user experience of the product. And you have the software that's kind of controlling the whole thing. Now, on this diagram, that looks really easy. My kids looked at this earlier. They said, hey, why aren't we just building stuff? And you can. If you go out and you get a small board, you can start building some high-tech products. But when you want to ship a real product, this actually becomes a big mess. A lot of these companies are using electronics, and electronics designers have their data in one system. The mechanical guys are designing their enclosures in another system. You have the sensors and actuators you're using are getting revised. They're getting changed. Even the chips on your board can get changed. Your software is trying to keep up with that, solving bugs, coming out with new features, and then having to get that into one consistent bundle and ship that out to a customer and have it work is an extraordinarily complex feat. Having all this data in one system, one consistent view, is exactly what Accelerated Device does. It puts all of this data in one place so that you can see it and you can release a consistent product out to your market. So Lewis, tell us a little bit about Accelerated Device.
So when you talk about Accelerated Device, it really takes the advantage of having a platform approach that we bring from the 3D experience. So when what we're going to talk about today, to make it very simple, is really product and product management and governance, design engineering, and manufacturing preparation. Now, these are the three key areas that when you're building a product that are kind of interconnected, and having a platform and that single source of truth really makes a huge difference. And using Accelerated Device, our goal here is to allow our customers to bring things to the market faster in an accelerated way.
So to start with that, we're going to start with the product and project governance. And this is really the area where we get teams to work together. We take the project management, how you organize your teams and the work that needs to get done, talk a little bit about release process or requirements and things like that, so that you have an organized product that you're going to bring to market. So here we look at the 3D experience platform and what it looks like. On the left, we're looking at some communities and some ideation. So there's a built-in ideation funnel in the product. People can go in and look at the ideas and they can make comments on them or they can like them. On the right, we have a view on the project planning app. So here we're going to go in and add in some tasks. And we say, for example, we want to add ventilation to the housing of the product. Then we can go in and we can assign people to it very easily in the product. And then use kind of drag and drop to do all the work. Here we're taking that task and we're assigning it to a milestone. And in addition, this whole solution of project management is web-based, but not just web-based in a PC browser. You can use it on any mobile device. So whenever you're out in the field or you're with customers, when COVID allows us to do so, you'll be able to get to this data. And it's not just about kind of viewing it. You can actually go in and modify it. So the project manager here is looking at it, he's adding some estimated days, but he's going to also add some content. So on the right-hand side, you see his bookmark editor. He's actually going to add some content directly into this so that the person using or going to be operating on this task, he actually knows the content that they're going to be working on. So since the PLM is in the same system or is the same system as the project management, all of those tasks have links directly to the actual content. So if we go in and we take a look in here in the web interface, he can drag that view from the Beamy, the attachment, and actually see it in a web interface. So this is the 3D data that task is going to be related to. So now if we look at it from an engineer standpoint, an engineer will have a kind of slightly different dashboard. They're completely configurable. The user's going to go in, he's going to be able to see his bill of materials on the left. On the right, he's starting to work into a change action. So he's got this task to make a change. He's going to assign a person to do it. He's going to make one of them a reviewer, the other an owner. And then he's going to say, okay, these are the things we want to change. So in order to make a better performance in terms of economy of battery, he's actually going to have to make some changes to the battery itself, make the battery life go longer. So he's going to take that, he's going to drag it into the proposed change that the engineer is going to work on. And then he's going to go over and see, right now there are no realized changes because the work isn't done yet. He's also going to put the context of what that engineer is going to be working on. So this battery is being changed, but in the context of the Beanie model, so that the engineer knows that it's going to be working inside the Beanie. In addition, this change is dependent on another change. So if he's going to be changing the battery, he needs to make sure that the mechanical frame has been updated as well. There's already a change action for the mechanical frame update. So he's just linking the two of them together. Once that's done, he can promote the maturity into in work, and the engineer can get started. So here we now that we've promoted it in work, since the previous parts were released, it automatically goes through and creates new revisions of the parts that the engineer is going to work on so that they will be in work and the engineer can start doing his job. So next we're going to move into the design and engineering space. The design and engineering is really where a lot of the meat of the work is getting done. So we've just talked about product and project governance, kind of the organization of the project. Design and engineering is where the engineers actually go in and get the things done. So here we've got Jack. Jack is going to log into the system. Jack is a designer, mechanical designer. When he logs in, he sees all the change actions here over on the right that he's got to work on. He's got a list of them. He's going to go in and look at the Beanie autonomy. So Beanie is the projector that we're working on. He's going to look at this change action to increase the autonomy that he was just assigned to. He's going to see the context in which he's working. There are dependencies, so he's going to see that there are dependencies on that, and he's going to be able to take and view the product that he wants to work on. So here he loads the battery and says, okay, that's what I want to work on, and just takes it and goes and clicks on SolidWorks. There is a SolidWorks icon in the interface. SolidWorks is another product from Dassault Systems. So Dassault Systems makes multiple CAD tools, makes CATIA, makes SolidWorks, as well as some web-based design applications. So we can start up SolidWorks just by selecting that battery, clicking on the SolidWorks icon. It'll bring up SolidWorks desktop with that content loaded. So he's ready to go. He's got his battery. Now what he's going to do is he's going to reserve that because of course he wants to lock it so nobody else is going to be making changes while he's doing that. And he's also going to tell the system that he's working under that change action so that all of his changes are being recorded and that is known for the traceability of what's happened to his battery. So he makes the physical design of the battery a little bit larger. This is just a sample of one of the operations he could do. Of course, we're not going to go into the details of SolidWorks. And then he sees that the battery is saved. He saves it locally and then pushes it up to the database. So here he's got a few options that if you wanted to check some options to different options for updating, you can. He simply saves that out. We see that the status symbol over here on the right now goes to a check mark. The save is done. All he has to do is unreserve it and his work is done. Now, once the work is done, he can, inside the interface, he can literally promote it to frozen. It's ready to be reviewed. He says his work for that change is done. He unhooks the change action and then can go back to the dashboard. So here he opens up the PLM services, goes over, clicks on dashboard, and we're back in the UI of the dashboard. Now, since he's in a dashboard as a web-based app, he just clicks the refresh button on the CA, goes over and refreshes the CA. And we see that the parts that he's just modified, so the realized changes, are now frozen. The CA is ready now to go through the approval process, so the next person in the line will be able to approve the changes he's made before they're sent out into production, make sure that they're coordinated with the rest of the design. Because there are other things going on. So this is just one part, as we said. A high-tech product is a complex device. There's electronics, there's software, et cetera. So we're going to see the next step. Louis, tell us a little bit about the electronics.
So just like like you've seen in the mechanical side, Sarah here is our electrical engineer, will get a notification of change that a new printed circuit board is needed in a product. And what she did is she opened up the platform. She's bringing over she had brought over the dimensions that had come from the mechanical engineer of the outline of that. And what she's doing now is she's going into the platform and calling up parts that she needs for the schematic. schematic. Now, one thing to note here, as she brings in the parts, you see that they show as an isometric, and as she brings the parts into the board, they get, based on the context of where you're putting them, they show up on the right schematic page. Now here, Sarah has finished the design. She hasn't laid out all the circuitry yet, but she's finished the placement of the devices, and she wants to check to make sure that all the schematic symbols are right and that everything's in there. So she checks it into the platform, and what she's seeing here is a view of it. She's making sure that everything looks good, but then she realizes that she needed to add the 2 sensors that were required. So she's going to go back into the system. She's going to go back and create the symbols that she needs, and she's going to go get them. She's added them to the schematic, and now they show up in the bill of materials. She's checking them off here to add them to the 3D Experience platform, and you'll see that once she brings them back in, the 2 big blocks, which are the sensors, are now part of the design seamlessly. So now what she's going to do is she's going to go back into it and basically hand it over to the mechanical side, and the mechanical folks are going to do fit up and change and see if there's any information. This can go back a few iterations. But one thing that's interesting is when Sarah had pushed that back, it became part of the controller. Part of the controller bill of materials. Now, with every good ECAD system or every good system, you need to have management of your parts and library control. So today we have a very robust system for allowing you to use your existing libraries and your existing components and putting them together. And here you're seeing the engineer putting a new part together, and he's putting together the schematic symbols, the 3D symbols, and then any kind of parameter information or parasitic or simulation information you may need for the part. And right here, he's going to go into it and pick the schematic symbol. So in this case, he's going to pick a capacity. You'll see a two little schematic sign. He's going to pick another part. In this case, he picked a cap from another device, puts it in. Now it's making the association. And now what he's going to do, he's going to put in the 3D package, or what the package geometry will look like. And he's picking the package from an existing library, or you could create a new one. Makes it very, very simple to do that. And then the last thing he's done is he's assigning the footprint that's used on the printed circuit board together. So what this new library management system, which is really powerful, allows you to have all of your design elements for your electronics and your mechanical all in one place, so that one part number has many different representation depending on what you're working with. And so what she's doing here is she's putting the parts back into the library and closing back out. And I'm going to hand this over to David.
Yeah. So after you've got your electronics, we of course have software that goes into any product. Now, the 3D Experience platform is not a source code control system in the sense of it will integrate with a source code control system like Git or Subversion or Design Sync. What we're seeing here, though, is this linking into that, and we're able to see that there are the different source files in that build. I believe this is looking at a Git repository. And what we want to track is not the individual files. We want to track the build that we're going to use, that we're going to deploy with our Beanie project when we release it. So here we see the Beanie build has an A version and a B version. The B version is still in work. So we switch over to the design developer, the guy who's actually going in and doing the code. And he's going to go in and he's going to add in some functions to make it a more saved battery time, battery electricity by having an eco mode. So he adds the C file, he adds the header to go along with that in the file system. And he's going to go in and do what coders do. He's going to write a bunch of code. He's going to go through, do all his tests and things like that, so that you're sure that you've got a quality build. And then once that's done, he's going to check it into Git the same way he would in any circumstance. So the objective here is not to change the way in which the designers work, because they're very comfortable with these tools. What we want is for them to continue using the existing tools, but provide a management layer on top of it where we can be sure which build of software is going into our product when it goes down the manufacturing line. Also, of course, these sorts of builds can happen and after the product is released as over-the-air updates. So we want to note this, a Beanie Eco Mode tag. Specifically, he's putting this code into a branch. And what we're going to do is take that tag and we're going to update to the 3D Experience saying, hey, this build is related to this tag. So in B1, which is still in work, we're going to take it, we're going to open it up. When we open it up, we see all the files, of course, there, and we can look at the properties of the build and tell it in the repository, we're no longer going to use the master branch. We're going to go off and use the eco build branch of this software development. That way we know that that build and that source code associated with it is the one that's going to be used in the overall Beanie product line. Now we can go in and we can look at those files. In this case, we're looking at source files. These could also be DLLs or EXEs or anything else, any compiled files, libraries, etc. Here we're just showing it for source code because it's easiest to view. So you're able to keep all of your software as objects in your PLM system and link it to, for example, different versions of boards or different versions of electronics, so that you're able to keep all of that in sync and deliver one consistent product to your assembly line, and also, once again, afterwards doing an over-the-air update. So once we're done with that, I think a lot of the mechanical guys would really need to be able to do some simulation and make sure the product performs the way as expected.
So what we're showing here is our simulation capabilities, and this is very interesting. What we're looking at here is what we call simulation trade-off. So we're running a bunch of different tests on the batteries, different configurations. We're looking at total capacity, power density, energy density, using different parameters and such, and running a bunch of virtual tests and trying to understand the way the system operates. And it really allows us to figure out what trade-offs we would like to take. So as we move forward in the system, I would like to see, we'll be able to see how the system moves forward. In here, so what you're seeing is the different types of power. So what's really common in most products is products really require physical abuse or get physical abuse. Wouldn't it be nice to know what the deformation is or what happens to a product in the case of a scenario where you drop it like this, and we can understand what happens to the system? Or even take a case where you've developed a new housing and you want to understand how much stress it can take. And what we're doing is we're collecting all this information, and we're being able to be able to make a what if trade-off. So what you've seen is different simulations taking place, and now looking at the KPIs or the requirements that we need, is we can really make trade-offs to understand what factors are the best ones for our design, and which parameters and which way we ran the solution is really the best to meet our product design needs. And it's really, really a powerful solution where you can look at many, many different factors of simulation at the same time. Now here what we're doing is we're doing a standard drop test to understand deformation of a product. You can see that we do this all day and every day, and a lot of companies do that in looking at the deformation of the product package. Now think about it as an electronics manufacturer. You need to put your products in a packaging. Packaging goes on a skid, may go on a ship. So we also provide the ability to look at what we call packaging solution, or look at what happens when you drop the package or you do swaying. You're in a ship and your boxes of shipping are swaying and so forth. You're getting relative motion. What's happening to the product inside and what's happening to your package? So we have the ability to go way beyond just the traditional, mechanical and electrical simulation, but being able to take your packaging solution all the way back into your design and engineering solutions.
Restarted. There we go. So after that, we're going to be talking about a little bit about the manufacturing side. So we've gone through, we've simulated the product, we've done our design work, we've done our electronics, we've done the software. Now what we want to make sure is that if we want to have a profitable product, first of all, we have to be able to manufacture it, which is very easy for engineers to go through and make products that cannot be actually manufactured. We also want to make sure they know how to be assembled, what the instructions are to do that. And we want to optimize that assembly line to make sure that the number of units coming off the line is as high as possible, so that we're reducing the cost. Whether you're using an EMS to do your manufacturing or an ODM, or if you're doing all of that externally and then doing your own assembly inside, knowing how that process is going to work is going to help reduce the unit cost on your product. So here we're going to take a cell phone. We're going to look at how do you create the manufacturing bill of materials. And this is using the same product structure that we had on the engineering side. So we start out with the engineering definition of the product. And in the tool, we load that up and say, hey, create a basic MBOM for me. And it will go through, we have some options and some guidance that we can do. And it's going to go generate the manufacturing bill of materials for me. And what we see here is now all the different parts that go in, or the substructures into that cell phone. And we can navigate around in that. So we can see what parts are used to assemble other parts. And we can also make those make-buy decisions. Some of those parts we're going to build and manufacture ourselves. Other ones we're going to buy on our own. We have, of course, since we've got the 3D in the system, we can go in and we can inspect the 3D. And then once we've got the manufacturing bill of materials, we want to actually look at how is it going to be assembled? What are all the steps that are going to be assembled? It's not generally one continuous process. It's going to be something that is very complex. We're going to assemble multiple parts in parallel and bring them together. So we want to analyze the timings on that. We want to understand what that assembly process is going to look like, and we can put in some estimates on how long we think it's going to take. Usually a good a manufacturing engineer can come up with a good estimate. Of course, that will be subject, we'll put in the real times a little bit later on. Now, once you have that, you want to be able to create a digital twin of your factory. Now, this doesn't necessarily have to be a full EMS partner. This is probably when you're going to be doing a final assembly on your own. You want to look at what the assembly process looks like. It may have some robots. You see some cobots here in the image. But there's also being able to add and remove stations so that you're able to optimize the flow of product through your factory and your assembly process. Here we look at a bigger example. Let's say that you have your actual factory built out. You have some parts which are, for example, these might be pick and place machines or other things, and manual assembly process later on. So we saw some of those manual assemblies in the last parts of the video. There they are in the context of the overall factory. Once we have that factory process and we have all the stations laid out, then we can go in and we can really optimize down to the level of what activity is going to happen at each station. The product out of the box will be able to do some of that automatic optimization for us. So we see here that we're getting pretty close to the tap time that we're expecting. We're not going over that tap time. And if we need to do some manual adjustment, of course we can do that manual adjustment. But by making the process plan and measuring at each stage, we're able to ensure that there's no bottlenecks in the middle of our assembly line slowing up and gumming up the works. So we have a smooth flow of product across the assembly and able to get the product out the door. So we asked earlier, why would you do accelerated device? Why do customers invest in accelerated device? Simply because it allows them to innovate faster. It allows you to accelerate your design and engineering iteration process so that you're able to get through your design faster. You can explore more design alternatives with those, being able to compare the different alternatives that we saw in the simulation part. We can also create the assembly process, which is key to the profitability of each product. And then through this entire process, we're reducing the number of prototypes built. There will always be prototypes built, but at the same time, if we can reduce the number of them, we can accelerate that because it takes time to build a prototype. And also, they're very expensive. So reduce the number of prototypes through physical preparation. So with that, that is accelerated device from Dassault Systems. Thank you, Louis, for your time. I think what we want to do now is open it up to any questions that you might have had during this presentation. It is quick. I know a lot of you may have some questions that have come up. You can either ask them here in the space below, or if you want to contact either myself or Louis after this, feel free. Okay, so the question we have here is, what electrical CAD packages are supported on the cloud? Louis, do you want to take that one?
Sure. Today, what we have capability of Altium, Cadence, and Zuken are the main packages that we support today with direct information onto into the 3D Experience platform.
And which Cadence is that?
That would be the Cadence Allegro today.
Cadence Allegro?
Soon to be the OrCAD, yeah.
Okay. Other questions? Which XPDM adapter is the best fit for the high-tech industry? I think that's kind of an open question. Really, when we look at the XPDM type adapters, it depends on where you're coming from and where you're going to. Absolutely. So you're going to end up with, if you're going from a cloud solution, Dassault's got now some adapters coming out of the cloud solution, or the on-premise solutions have a lot more options. There are some third-party options out there. Also, I think they're coming out of some companies out of Germany that are very good, but it also depends on what data you're going to transfer and what the target system is. Other questions? can simulations be run on cloud hardware? So that's a really interesting one. There are a certain number of simulations. For example, a lot of the finite element analysis simulations can be run on cloud hardware, which is really interesting because when you think about the amount of hardware that's necessary when you're running a cloud simulation, those boxes are expensive and you're going to buy them, but most of the time they're going to be sitting there. One of the things you can do with the Dassault Systems simulation solutions is do all your meshing locally. So you're going to do your meshing locally, but then push up and parallelize those the simulations on the cloud. So you can say, I'm just going to use a certain amount of capacity on the cloud. And Dassault has a way of measuring that and charging you for it, but you're only paying for the parts that you actually use, as opposed to having a box sitting around that you have to keep loaded all the time. I meant for SAP. There are actually multiple connectors for SAP. Once again, if you want to contact me outside of this, we can go in and take a look at that. There are, I think, three or four SAP connectors available for the 3D Experience platform.
SAP is a broad term.
Yeah, there's a lot of SAP too. Yeah, but if you want to send me a mail afterwards, we can dig into that with you.
Is there any other questions? Let's see.
Okay. I don't see any other questions. If you do have questions or comments, please put them in the either in if you're looking in LinkedIn, in the comments in LinkedIn. I hope you all enjoyed the presentation today. Thank you again, Louis, for helping us out with this.
Thank everybody for attending.
Always a pleasure to work with you, and thank you everybody for attending. Feel free to contact us going forward, and we'll let you know when the next XD Innovations technical webcast will be. Thank you. Have a great day.